Welcome to the Digital Certificates, Client-Server Certificate Configuration and Authentication video. This video will provide an overview of types of SSL client and server configurations and how SSL works between the client and server. This video will cover how to understand the different types of SSL client and server configurations, recognize the client and server certificate and key ring key store sample configurations, and know how certificates are used in client and client-server SSL authentication. What is SSL? SSL, Secure Sockets Layer, is a security technology, a protocol for establishing an authenticated and encrypted link between a client and server. There are two basic types of client-server configurations. First, there is server authentication, where just the server identity is authenticated using certificates. This is where the client authenticates or verifies the identity of the server that it is connecting to. For example, if you are running a Windows client application to connect to a ZOS server on the mainframe to access information, the client application can verify that it is connected to a known trusted server. Typically with server authentication, after the client authenticates the server using a server certificate, the server will present the client with a sign-on screen to authenticate the client using a user ID and password rather than a certificate. The second type of configuration is client and server authentication. This is when the server is authenticated first and then client identity is authenticated by the server, where both the server and the client are authenticated using certificates. Note that this is not as common as just server authentication. There are several different types of client-server configurations based on what environment or platform the client and the server reside on. Here are several examples. The primary purpose of this course is to cover the ZOS configuration, where either the client or the server resides on ZOS, and one of the ZOS ESMs or external security managers, such as ACF2, Top Secret, or RACF, is used to configure the certificates. The other non-ZOS environments have their own utilities to set up certificates for a client and/or server. In a ZOS environment, key rings are used to associate certificates together for a client or server task. In other non-ZOS environments, key stores are used to hold certificates for a client or server task. So what certificates are needed for the two different types of configurations? For server authentication, where only the server is being authenticated, the server needs two certificates: its own personal certificate and the cert-auth certificate that signed it. The client only needs one certificate, the server's cert-auth certificate. For server and client authentication, where both the server and the client are being authenticated, the server requires three certificates: its own server personal certificate, the cert-auth certificate that signed it, and the cert-auth certificate that signed the client's personal certificate. The client also requires three certificates: the cert-auth certificate that signed the server's personal certificate, its own client personal certificate, and the cert-auth certificate that signed it. Once the client and server are identified, the required certificates can be deployed and installed into the appropriate key rings or key stores. Next, we will take a look at three sample configurations. The first example is a Windows client and a ZOS server. When a client attempts to connect to a server, the server will send the client its personal certificate and public key for the client to authenticate. The ZOS server obtains this information from the certificates attached to its key ring. The Windows client will then need the server's cert-auth signing certificate in its key store in order for the server certificate to be authenticated. The next example is a ZOS client and a Linux server. The ZOS client will need the server's cert-auth signing certificate in its key ring. The Linux server will need its own server certificate and the cert-auth certificate that signed it in its key store. When the ZOS client attempts to connect to the Linux server will send back personal certificate and public key for the ZOS client to authenticate. The last example is a ZOS client and a ZOS server. The ZOS server will need its own server certificate and the cert-auth certificate that signed it in its key ring. The ZOS client will need the server's cert-auth signing certificate in its key ring. When a ZOS client connects to a ZOS server, the ZOS server sends its personal certificate and public key to the client for authentication. We have already established which certificates are required on the client and the server side. Now, let's take a look at how the certificates are used with server authentication. On the left, we have the client with its key ring, and on the right, we have the server with its key ring. First, the client will initiate the session with the server. Next, the server responds and sends its personal server certificate to the client. Then the client will authenticate the server's personal certificate. If the server's certificate is authenticated, that verifies the identity of the server, so a secure connection can be established. Here are the details on the server authentication process. First, the client connects to a server that is secured with SSL, HTTPS, and the client requests that the server identify itself. Next, the server sends a copy of its personal certificate, including the server's public key. The client then checks the server's personal certificate against a list of trusted Auth certificates and verifies that the certificate is valid for the server that it is connecting to. If the client trusts the certificate, it creates, encrypts, and sends back a symmetric session key using the server's public key. Then the server decrypts the symmetric session key using its private key and sends back an acknowledgement encrypted with the session key to start the encrypted session. And at that point, the server and client will encrypt all transmitted data with the session key. Here is an example of both client and server authentication. In blue are the same certificates that were required for server authentication. Once again, on the left we have the client with its key ring, and on the right we have the server with its key ring. Now, in addition to the certificates used for server authentication shown in blue, in red, we see the certificates that are required for client authentication, which have been added to the client and the server's key rings. So, let's take a look how the certificates are used with client and server authentication. First, the same process for server authentication is done. After the server is authenticated, the client will send its personal certificate to the server. Then the server will authenticate the client's personal certificate. If the personal certificate is authenticated, that verifies the identity of the client. So both the server and client are authenticated and a secure connection can be established. Here are the details on the server and client authentication process. First, the client connects to a server secured with SSL, HTTPS, and requests that the server identify itself. Then the server sends a copy of its personal certificate, including the server's public key and a request for the client's personal certificate. Client checks the server's personal certificate against a list of trusted CAs to validate the server certificate. If the client trusts the server's certificate, it creates, encrypts, and sends back a symmetric session key using the server's public key and the client's personal certificate. Then the server checks the client's certificate against a list of trusted Auth certificates to validate the client's certificate. If the client is trusted, the server decrypts the symmetric session key using its private key and sends back an acknowledgement encrypted with the session key to start the encrypted session. At that point, the server and client will encrypt all transmitted data with the session key. This video showed you how to identify different types of SSL client and server configurations, understand the client and server certificate and key ring key store are configured, recognize how certificates are used in client and client-server SSL authentication. Thank you for watching this video of client-server certificate configuration and authentication overview.